Welcome to Schroeder's classes. Today we are going to be dealing with some different sums on practical statistics. You can call or WhatsApp at the number given on the screen for any doubts or for more videos on our courses. Let's see our first sum. A customer service department of an organization keeps record of the customers arrived to make complaints. Let X be the number of customers arrived per day for making complaints about their services. The record for the 90 consecutive days are given in the following table. Now we need to fit our Poisson distribution to the above data. We also need to fit our binomial distribution to the same frequency distribution. We need to figure out which distribution is better fit to the data. Let's see how to do this. Here, sample mean X bar equals to 0 into 54 plus 1 into 26 plus 2 into 8 plus 3 into 2 whole divided by 90, which equals to 0.53. Now equating X bar and lambda, we have an estimate of lambda hat, which equals to 0.53. Hence the fitted Poisson probabilities are fx equals to p capital X equals to small x, which is equals to e to power minus 0.53 into 0.53 to the power x by x factorial, where x is equals to 0, 1, 2 ... till infinity. Now the expected and observed frequencies are tabulated below. Now this is how we have fit a very good data into the Poisson distribution. This is what the table will look like. The expected frequency has been calculated and rounded off to 8 to make the total 90 in this case. Now we find the observed frequency. Now we do for binomial probabilities. Now we fit a binomial distribution with n equals to 3. The estimate of p, which is p hat, equals to x bar by n, which equals to 0.53 that we had calculated by 3, which roughly translates to 0.18. Now the binomial probabilities will be p capital X equals to x equals to 3cx 0.18 to the power x into 0.82, which is 1 minus 0.8, 3 minus x, and x has the value 0, 1, 2 and 3. Now the expected and observed frequencies will be tabulated below just like before. Thus these are the observed values. Here we have fit data which is satisfactory, but the Poisson distribution gives a better fit to the given data. Now we have the following question. It has been observed over a long period of time that a particular rifleman can hit a target on a single trial with probability 0.7. Suppose that he fires 5 shots at the target. Now we need to write down the entire probability distribution of the number of times the rifleman hits the target in 5 shots. Hence we need to find the probability that he will hit the target in the 3 cases, at least once, exactly twice, at most 4 times. We also need to write the CDF for all values of x. Let's see how to do this. We assume that x equals to number of times the rifleman hits the target in 5 shots. Also we assume that the shots are independent of each other. Now x is binomially distributed with n equals to 5 and p equals to 0.7. Therefore, the PMF equals fx equals to p capital X equals to x, which equals 5x cx 0.7 whole to the power x into 0.3, that is 1 minus 0.7 is 5 minus x, where x ranges from 0, 1, 2, 3, 4 and 5. Now we'll create a table based on these values. This is the probability distribution table of x. Now we'll calculate the case when he is able to hit the target at least once. Number 1, probability x greater than 1 equals to probability x equals to 1 plus probability x equals to 2 plus till probability x equals to 5. This equals 1 minus probability x equals to 0, which is equals to 1 minus 5 C0, which into 0.7 to the power 0 into 0.3 to the power 5. Now the value comes as 0.9976. Note that instead of calculating probability x equals to 1, x equals to 2, x equals to 5, we use the complement rule to obtain the required probability here. It is faster and easier to calculate. Now we find the probability that he will hit the target exactly twice, that is probability x equals to 2, which is equals to 5c2 into 0.7 to the power 2 into 0.3 to the power 3, which equals 0.1323. And lastly, we see for the case that he hits the target at most 4 times, that is probability x less than 4 equals 1 minus probability x equals to 5. Again using the complement rule, 1 minus 5c5 into 0.7 to the power 5 equals 0.8319. The CDF is shown in the last column of the above table, that is fx equals to p x less than x. I hope you understood each and every step that I did. Please like, subscribe on WhatsApp or call us for any doubts or for full videos on our courses.